This is our lecture number 2. In this video, we will learn about formation of differential equation. In previous video, we learned how we can find a degree and order of a differential equation. So there are steps can easily calculate formation of differential equation. So our first step is write down from our first step is write down the equations. Whatever they have given you problems, from that problem you should extract equation from that problems. After writing, calculate number of arbitrary constant. So after calculating arbitrary constant, you may get one arbitrary constant, you may find two arbitrary constants, three arbitrary constants. So you have to differentiate equation, it means from step 1 with respect to x equal to the number of arbitrary constant. It means that equation successively it is equal to the number of arbitrary constants, and number of arbitrary constant which present in a equation which you extract from a given problem. So you need to just successfully differentiate that equation equal to the number of arbitrary constant. After differentiating, eliminate arbitrary constant from step 3. So after successive differentiation, you get, after successive differentiation of equation, you get differential equation, but it may be possible you are not able to eliminate arbitrary constant from that. So in our upcoming session, we will solve some problems that on successive differentiation we can, in some problem we may eliminate arbitrary constant after by doing a successive differentiation, but in other form, if also in other problem you may find that after doing successive differentiation our arbitrary constant is not eliminating. So, and there is a condition for a differential equation that in our first lecture we have seen what is the definition of a differential equation. It means it contains differential coefficient and free from any arbitrary constant or radicals. Okay, it should be free from that. So our first step is for that definition. Okay, it means you have to construct a differential equations that is free from any arbitrary constant. So if we go to the problem number 1, because after solving problem it will clear to you. Our first problem I am taking, find the differential equation of all non-vertical lines in xy plane. Just first consider, what do you mean by non-vertical lines? It means if you have xy plane, lines should not be parallel to y-axis. You have to consider only it may be line in this form, it may be horizontal, it may be in this form. So you have to just form the differential equation for such type of lines. Okay, you don't need to include the line which is parallel to y-axis. So generally our first step, step 1, the equation for non-vertical line. So you know what is the equation of a straight line, y equal to mx plus c. So we have completed our first step, that we are able to extract equation from our given statement problems. So our next step, and here you are observing this is the arbitrary constant m and c. Here we have two arbitrary constant. It means we have to differentiate given equation two times. So on differentiating with respect to x, we have to differentiate two times. So d2y in step 2 differentiate equation with respect to x. So dy upon dx equal to m, and c is a constant, it will become 0, and again differentiating this equation with respect to 1, d2y upon dx2 equal to 0. So here observe, in step 2, what is our step 2? You have to differentiate equation, that equation which you get in from step 1 equal to number of arbitrary constant, and that if that equation is free from arbitrary constant, so that is our simple differential equation. You got it? So here in our these problems, after successive differentiation, our arbitrary constant is already removed. So this is our required differential equation. If arbitrary constant is not removed, so we will try to eliminate arbitrary constant from that equation. Okay, by doing simple algebra. But you keep in mind that differential equations should be free from any arbitrary constant. So I hope you understand these problems. So I am taking problem number 2. One thing. Just tell me, what is the order of this equation? Here is second order derivative, it means order equal to 2, and degree, the power of highest order differential coefficients, here power is 1. So order on and degree of this given differential equation is 2 and 1. second degree differential equation of order degree 1. So our next problem is find the differential equation of the family of curves represented by c y plus c to the power whole x square equal to x to the power 3. So in problem you don't need to extract equation because here already you have a given equation which represent family of curves. So our first step is done. So we have given equation which represent family of curves, that is c y plus c to the power whole s y to x to the power 3. So here arbitrary constant is arbitrary constant c, that is 1. So in step number 2 differentiate, write down this is the equation number 1, differentiate equation 1 with respect to x. On differentiating you will get 2c y plus c to y dash equal to 3x square. This is the equation number 2. So our second step you should eliminate the arbitrary constant from that. So how we can do? Dividing equation 1 by 2. So in dividing equation 1 we will get y plus c to the power whole square upon 2c y plus c y dash equal to x to the power q upon 3x to the power x square. So on cancelling terms you will get y plus c upon 2y dash equal to x upon 3. And you can write after arranging these terms y plus c equal to 2 by 3x y dash. From here you can write c in form of 2 by 3 x y dash minus y. So finally you are able to find the value of c. So in next step what you need to do, this is the simple algebra you can do in your manner. I am doing in my manner, putting value of c in equation 2. What is our equation 2? 2c y plus c y dash equal to 3x square. This is our equation number 2. Put value of c. 2, after putting you will get 2 to 3x y dash minus y plus 2y3 xy dash minus y plus y dash into y dash equal to 3x square. To just simplify this, 4 by 3 xy dash minus 2y 2 by 3 xy dash, because y will cancel out, into y dash equal to 3x square. Just take LCM. 4xy dash minus 12y upon 3 into 2 by 3 xy dash y dash equal to 3x square. So 3 into 3, it is equal to 9. So 4xy dash minus 12y 2xy dash y dash equal to 27x square. Just multiply 8x square y dash to square minus 24xy y dash equal to 27x square. Take x common. So finally you will get 8xy dash to the power square minus 24y dash to the square equal to 27x, and multiplying you will get here just shift 8xy dash 3 minus 27x equal to 24. We did here mistake. 6y 12xy 12, here 12y into y dash square. Take x common, 8y cube minus 27 equal to 12y dash square. So after getting, you can simply write 8 dy upon dx to the power 3 minus 27 12y into dy by dx square. So after simplifying this, finally we get x bracket 8 dy by dx upon 3 minus 27 equal to 12y dy by dx. Just observe here, this differential equation, it is free from any arbitrary constant. So this is our final differential equation, and just you keep in mind that, please tell me what is the order. So highest order differential coefficient. So just tell me what is the order of this given differential equation is. Highest order differential equation is presented. Highest order differential equation. So order is 1. And what is our degree? Degree is the power of highest order derivative. So highest power is 3. So degree is 3. So in this manner we have solved problem number 2, that is find the differential equation of family of curves represented by cy plus c square equal to x to the power 3. So you don't do any extra, you just follow the steps which is stated above, and after following that step you are able to find the solution of a you are able to form the differential equation from a given problems. So this is our last problem, that is problem number 3. So in this problem I have taken these problems for elimination process. So how we can eliminate? So problem is eliminate m from 1 minus s square plus 1 minus y square equal to m x minus y. So in this problem you have to just eliminate m from these equations. So how can you do that? So if you I am putting x equal to sine theta and y equal to sine phi. So just I am doing, because I am able let for that successive differential equation. So our differentiation should be if we are going to differentiate these problems. 1.2x square into 2x dy by dx equal to m 1 minus dy by dx. So this is our equation 2 and this is our equation 1 just derived in, and after that you can remove the value of m. You can remove m, but your calculation would be your calculation would become tough. Okay, if you follow this in this manner you are easily remove, but your calculation would become tough. Okay, so just I am considering putting x equal to sine theta. So after putting you will get 1 minus sine square theta plus 1 minus sine square phi equal to m sine theta plus sine phi. From that we get cos theta equal to cos phi equal to 2m cos theta plus phi upon 2 sin theta minus phi upon 2. You can also write in the form of using cos a plus cos b, 2 cos theta plus phi upon 2 cos theta minus phi upon 2 equal to 2m cos theta plus phi by 2 sin theta minus phi by 2. It will cancel out, 2 will cancel out. So finally cot theta minus phi by 2 equal to m. From here you can get theta minus phi upon 2 equal to cot inverse m. Theta minus phi equal to 2 cot inverse m. So this is we get. So what is our theta? We can write theta to sine inverse x minus sine inverse y equal to 2 cot inverse m. So this is our constant term. Just you need to keep in mind it. So differentiate with respect to x. What we will get? 1 upon 1 minus s square minus 1 upon 1 minus y square dy by dx equal to 0. So from here we get dy by dx equal to 1 minus y square upon 1 minus s square. So finally we get differential equation by and we are also able to eliminate the arbitrary constant m. And homework for you that you just try these problems by not putting x equal to sine theta and y equal to sine phi. Just use you follow in this manner and check your answer that you are able to get this form of a differential equation. Here order is 1 and degree is also 1. So I am stopping here. In our next video we will solve more problems on how we form differential equations. So thank you.